factor each of these completely. Okay? Well, to factor this one, you might think, oh wait, two numbers with a minus in the middle? Well, I could just do the shortcut, right? You can't do the shortcut because you can't take the square root of 2 or the square root of 50. That doesn't give you a whole number. Okay? So what you could do is you could see that, oh, well, the 2 in the 50, I could take out a GCF. If you notice all the answers, they all have a 2, most of them have a 2 taken out. That's because I could take the GCF. So this, take the GCF, the common factor is 2, but there's no common variables for x, so just the 2, and then 2 times 25 equals 50. And now you can be like, okay, well, we'll have to factor x squared minus 25. Okay, and that's two numbers minus in the middle, and they're both perfect squares, so I could just take the square root of both. And now let's set up our factors, and we take the square root of x squared, it's x, and take the square root of 25, that's 5 and 5, and then the signs will be opposite for each factor, plus and minus. Here you can do minus and plus either way. And then you know that a is the answer. Or again, you can pull this x squared minus 25 off the side and use the x and just the but you need to include the missing term, which is 0, the middle term. And then you could do the x and do negative 25 on top, 0 on the bottom. Two numbers that multiply to negative 25 but add to 0, whether it be 5 and 5, and one of them has to be negative. Oops. So then I know that the negative 5 would tell me this factor, and the positive 5 would tell me this factor. Because again, if there's, as long as you don't have a coefficient bigger than 1 in front of the x squared, you can go straight to your binomials or your factors and put x plus 5 and x minus 5. But then don't forget the GCF that we did in the first step. Okay. Okay, next one. Okay, here, let's see. I have the common factors between these two numbers. So what I can do is just do GCF. So first look at the 3 and the 6. I could take out a 3 for both of those. And then the variables, I could take out at least one r. And then 3 times what equals 3? Well, it's just 1, so I don't need to write that. Then r squared times, r times what equals r squared? Well, it's r. And then minus. And then 3 times what equals 6? That's 2. And then r times what equals r? Just 1, so I don't need to write that. So there is that same expression factor. So it's C. Okay. Number 19. Okay, now here I have a quadratic expression, and the first term is 1. Okay, or the squared term has a 1, so then all I have to do here is the x. And with the x, the first times the last number goes on top, so 1 times 18. And then the middle number, or middle coefficient, goes on the bottom. Okay? And then I have to figure out what two numbers multiply to 18, but add to a negative 11. Well, I know 9 and 2. I can make 9 and 2 with 9 and 2, I can make 11. But it's negative, so that means they both have to be negative. Because a negative times a negative equals a positive 18. And then negative plus a negative will equal negative 11. And right away, I know that B is going to be my answer. Because when I write this out, it will be M minus 9 and M minus 2. And that 2 came from there, and the 9 came from there. Okay? So now, some of you guys were thinking like, wait, isn't it supposed to be positive 9 and positive 2? That's only when you are asked to solve it. And you have to find the solution. Then you know that the answers are opposite. So if you had to solve this, M would equal 9 and M would equal 2. But that's not what it's asking for. It's just asking for you to factor it. Okay? Alright, so now, again, this one I only have to do the x, because that first term is 1. Our first coefficient is 1. So number in the top, 1 times 7. Number in the bottom, middle term, our middle coefficient. And then the two numbers here would be 7 and 1. That's the only thing that multiplies to 7. So then that means I have to look for a positive 7 and a positive 1. Well, that would be C. Okay. Now find the value of C that completes the square. Okay, if you remember when we were solving quadratics, one method was completing the square. Okay, so to complete the square, the formula was you take the middle number, B, you divide it by 2, and then you square it. So in other words, you take 14 in this case, and you divide it by 2, and then you're going to square it. So 14 divided by 2 is 7, then 7 squared is 49, and that's completing the square. Okay. Now we're going to solve each of these quadratic equations. Okay, now you are going to solve here. Okay, so here let's try the x with this first one. Put 1 times 28, and then 11 on the bottom. Well, I know the numbers that multiply to 28 are 7 and 4, and that works because 7 plus 4 equals 11, and 7 times 4 equals 28. So now I have m plus 7 and m plus 4. And what I told you guys is that the variable is a liar, okay? So your answers will be -7 and -4, because m or x or y, it's a liar. If you have a number next to a variable, it's the opposite. And really what I'm doing is I'm taking this factor and making it equal 0, and I'm solving the equation. So -7 minus 7, m equals -7. Okay, so then I know my answer would be C, because they're both negative. So you gotta be careful here, is that when you get your factors, remember that your answer is going to be the opposite. Okay? Or again, you can just pull off this whole thing off to the side, set it equal to 0, because basically we were looking for a number that if I plug it in here, it makes it equal 0. That's why we call it the zero product property. We're looking for numbers that if I plug this 7 here to m, it'll make it all equal 0. -7 plus 7. Okay, so now let's do the same thing here. Now here, if you notice, that first term is not 1 anymore, it's a 7. Okay, so what I'd have to do is not only the x, but I'll have to do the x and the box. Okay, so now 12 times 7, well, no, it's negative, and then it will be 84, and then the bottom will put 25. But then, you know, you could sit there and try to figure out the numbers, and some of you guys might recognize it right away. Another way to do it would be do the quadratic formula. Okay, so I'm going to show you guys a different way. Actually, okay, so let's do the quadratic formula. In the quadratic formula, you need to find a, b, and c. So a is 7, 25 is b, and -12 is c. Remember, the formula is -b plus or minus square root of b squared minus 4ac over 2a. Okay, so now just plug in all the factors, or plug in all the numbers. So now -25 plus and minus the square root of b squared, so 25 squared, minus 4ac. Times a, which is 7, times c, which is -12, all over 2 times a, which is 7. Okay, and what you could do is just simply plug all this in the calculator. Okay, but just remember, the first time you do it, you're going to want to do it with plus, and the second time you're going to want to do it, with minus. And I'll show you how to do that in a minute. But first, let's just evaluate it without the calculator. Okay, so rewrite this. First, we work on the square inside the square root. 25 squared . 25 squared. 625. Okay, so 625. And let's see, I'm going to have 4. Let's clear this. 4 times 7 times 12. It's going to equal 336. And I also notice there's a negative and another negative here, so that'll make it positive. So 336. Ooh, it's a big number, right? Okay, and the bottom, 14. And then let's add 36. Add it to 625. And let's just see if we can take the square root of that. So let's do square root of 961. So square root 961. Works out, 31. Okay, so plus or minus, then I got 961, just so you know. Okay, and then I took the square root of 961. And I got 31. And now the first answer is going to be negative 25 plus 31, which is 6 over 14. And the second answer is going to be negative 25 minus 31, which is negative 56. Excuse me, over 14. And then let's see if I can reduce these two numbers here. So first, 6 over 14, that's going to be x equals, I can divide 2 into both of those, so I get 3 over 7. And then for the second one, let's see, can I divide 56 into 14, or 14 into 56? Let's check it out. Let's do 56 negative divided by 14. Works out, negative 4. Okay, so now the other answer would be negative 4. And there's my answers. Okay, so you could also do the x in the box. You could do that, but the quadratic formula would probably be a little safer, just because your numbers get pretty big and you can make more errors if you use a different method. Also forgot to mention that your answer for that one would be A. And actually, we didn't even need to find the negative 4. We only need to find one of them, because 3 over 7 is the only answer that has, sorry, A is the only answer that has 3 over 7 for the x. So, all right, so moving over here to number 24. Okay, so now in order to do number 24, we got to decide what we're going to do first. Well, I could try the x, but what I need to do before I try the x is I need to get this to equal 0. If you notice, all the other problems, the equation is equal to 0 here and here. And you need to have that before you start solving these quadratics. The only time you don't need it to equal 0 is when you complete the square. That's not what we're doing here. Okay, so I need to add 8 to make that 0 on that side. And now my new equation, I'll write it down here since I'm running out of room, is negative 22 plus 8, and that would be negative 14 equals 8. So let's put negative 14 up here, 5 here. Two numbers I think would be 7 and 2. Okay, so, and one of them has to be negative, because they have to multiply to negative, and that'll have to be the 2, because 7 minus 2 is positive 5. And again, if this number is positive, then you know your biggest number should be positive. Okay, so now I'll write up my factors. So now it should be x plus 7 and x minus 2. But just because it's plus 7 doesn't mean that's our answer. Our answer is the opposite of that, because we would say, what do I plug in here to make it 0? Well, negative 7 would make it 0. So negative 7, and then here, the opposite of negative 2, which is 2. And as some of you guys that know me, I say x is a liar. If you have a number next to the x, it's lying to you. So it's not positive, it's negative. It's not negative, it's positive. Okay, so that would be this one here, D. Positive 2 and negative 7. Okay? Okay, so now, moving on to the next one. Okay, now here's a case where all the numbers, if you notice, they can all have a common factor, and it's 2. So what I could do is I could divide every one of these by 2. Okay? So if I divide everything by 2, that might make things easier for us. Okay, and of course I do that with every single term in our equation. So now I have n squared plus n equals 1 equals 0. I don't know if this is going to work, but let's go ahead and give it a shot. We always want to try to do the x first. So, okay, so now let's put 1 up here, 1 down here. The only numbers that multiply are 1 and 1. Well, that's definitely not going to work because you can't subtract, add, or do whatever to make a 1 down here. So that's not going to work. So I can't do completing the square either because this number is odd. If it was even, I could, but odd just didn't work out. Okay, so let's go ahead and do the quadratic formula. So a is 1, b is also 1, and c is negative 1. Okay, so let's plug them in. So now we get negative 1 for b, and then plus or minus the square root of b squared, which is 1, minus 4 times a1 times c, which is negative 1, and then all over 2 times 1. Lots of 1s. Okay, so let's evaluate this. So we get negative 1 plus and minus. Okay, so we're going to have negative 4 times 1 times negative 1. Well, that's just going to be positive 4, so 1 plus 4. All over 2 times 1, which is 2. And you guys probably already see what the answer is here, because when I add this 1 and 4, I'm going to get 5. So I'll get negative 1 plus or minus the square root of 5, all over 2, and we know that that is b. Okay? Okay, so now, this one, what do we do here? Well, first I need to rearrange the equation. So we want all our terms on the left, so we have only just one term on the right. So let's subtract that x from both sides. And just remember, this x, there's no other term like it. You have x squared over here, and then you have a negative 5, but they're not like the x. So you're not going to subtract that x either from the 5 or the 2x squared. You're basically just going to move it to the other side. So now this becomes 2x minus x minus 5. Okay? So we know that if I do the x, I'm going to have to do the box as well, because that first term is bigger than 1. Okay, so let's go ahead and see what we can get here. So first term times the last term, 2 times negative 5. And on the bottom, the middle term, or middle coefficient. Okay, so the only numbers that multiply 10 are 5 and 2. So that's not going to work. Okay, and as you can see, you probably already noticed that the solutions are all in that kind of quadratic looking, kind of looking like the formula, so obviously we're going to have to do that. So a equals 2, b equals negative 1, c equals negative 5. Plug them all in. So remember, b is negative 1, so there's already, in the formula, there's already a negative. So that means, because this is negative, and there's already a negative in there, that's going to become positive eventually. So now negative 1 squared minus 4 times a, which is 2, times c, which is negative 5, and then 2 times 2. Okay, so now let's evaluate all this, simplify it. So negative, again, like I said, negative times a negative, that's positive. Then the inside here, I'll have b squared, or sorry, negative 1 squared, which is 1. Then negative 4 times 2 is negative 8, times negative 5 is 40, so plus 40, all over 2 times 2, 4. Okay? Well, right away, I can already notice what the answer is before I even add this 40 and 1. It's got to be a, because that's the only one that has a denominator of 4. And from the beginning, I probably could have noticed that before I even did this math. 2 times 2 is 4. Use those clues to figure out the answers, right? Okay? Then just to finish it off, add the inside of the square root. And there's your answer. You split it into 2, you're going to have a plus and a minus solution. Okay? Okay, now, to kind of zoom out here to see all this. Question is, it says gets the graph of each function, but really the question is, which one of these graphs is this function up here above? Okay, so first of all, let's do some elimination. Well, we know it's negative, and they all go down. Okay, so we're going to have to do a little bit more guessing work here. So I do know that the y-intercept is going to be -7, because when you have it in standard form, the last number is the y-intercept. Okay, so the y-intercept is 0 and -7. Okay, because basically if I know that every y-intercept has x as 0 for the x value, so if I plug in 0 here and here for x, I end up with -7. Okay, so -7, well, it looks like this b has it, so a does not, neither does c, and neither does d. So there's our answer. So all we had to do was find that the y-intercept there. Okay, so now the next one. Okay, so it's a -x squared, so then we know it has to go down, just like this one was negative, so this all had to go down. So I know it's not d, okay, because it should be going down. Okay, the next thing is, what's the y-intercept? The y-intercept is 1, or it's at 0, 1. Okay, so that could be a, not b, but it also could be c. Okay, so now we have to figure out, well, what's the difference? Well, it looks like the vertex here is at 1 and 2, and the vertex here is at -1 and 2. So the question is, which vertex is this equation? Well, to find the vertex, we do -b over 2a, and that will tell us the x value. And that's all we really need to find. Basically, it should, if it's correct, it should equal the x value either -1 or 1. Okay, so let's plug in our values. So b is 2, so plug it in. There's a negative out there, so don't forget about it in the formula. And then 2 times a, which is -1. Okay, and I already know this is going to be positive because I have a -1 and a negative here and negative here. So this would be -2 over -2, which is equal to 1. So the x value of the vertex should be 1, and that would be C.